In this tutorial we're going to look at simultaneous equations and we're going to look right the way through them. Now, the first method we can use is elimination. Now, to eliminate, what we ideally want to do is ensure that either the x's are the same or the y's are the same. That's our first move. If you've got them the same already, so for example if you have 2x plus 3y is equal to 5 and then x plus 3y is equal to 1, then you know that you've got something quite nice and straightforward, that these two are the same. It rarely happens though. If it does, that's nice. What we need to do then, if we're going to use the elimination technique, is the following. I can either make the x's the same or I can make the y's the same. I'm going to make the y's the same and I'm going to just double this bottom one right here. So equation 1 is the top one, and that's x plus 2y is equal to 5. The second equation, I'm going to multiply it by 2. 6x plus 2y is going to equal 10. Now, these two numbers are the same. My next move is to study the sign in front of them. If the signs are the same, we subtract downwards. If they're different, we just add them. You might want to rewrite this as number 1 under number 2. So we end up with x plus 2y is equal to 5. So if you think it's easier to do that, you can do. And then all you're going to do is subtract downwards. 6x minus x is going to give me 5x. 2y minus 2y is 0, and now we've eliminated the y's. 10 minus 5 is 5. And of course, dividing both sides by 5, x is equal to 1. We then take our value of 1 and feed it back through to solve for y. So if we do that, we've got 1 plus 2y is going to equal 5. Subtract the 1 from both sides, 2y is going to equal 4, and then y equals 2. So our answers are x is equal to 1 and y is equal to 2. And then all we have to do is check that those both fit in and satisfy the equation, which I'll allow you to do. Now, let's have a look at another scenario. Let's have a look at this one. Now this time I'm not going to make the middle ones the same. I'm going to make the first ones the same because I know that I can just multiply this bottom one to get 3x rather than multiplying both of these, because I'd have to make them into tens. So equation number 1, the top one, 3x plus 2y is going to equal 19. Equation 2, the bottom one, I'm going to multiply by 3. 3x plus 15y is equal to 45. Now, what we've got here, and again, I'm going to rewrite equation number 1 under number 2, 3x plus 2y is equal to 19. We've got the scenario where now the x's are the same. And the main concern here is what the students struggle with is the idea, do they subtract or add? Well, if we're not told that they're negative, they're positive, aren't they? So it's positive, so we're going to subtract downwards. 3x minus 3x disappears. 15y minus 2y is 13y, and 45 minus 19 is 26. So we're going to end up with y is equal to 2. Substituting that back in, we end up now with 3x plus 2 lots of y, well y is 2, 3x plus 4 is equal to 19, 3x is equal to 15, and x is equal to 5. So this is the technique of elimination. We're just eliminating it. So there are your two solutions, and check they fit both. If we check, x is 5 and y is 2. 5 plus 5 lots of 2 is certainly 15. Check them both. So this is called elimination. Okay, let's look at this scenario right here. We've got equation 1, 3x plus 4y is equal to 2. And then equation 2 is 7x minus 5y is equal to 9. We can either make the x's the same or we can make the y's the same to eliminate them. Now what you'll see here is that these, none of them will just double up or triple up to go into the next. So we're going to have to get the lowest common multiple. The lowest common multiple of 3 and 7 is 21. The lowest common multiple of 4 and 5 is 20. The way I like to do it is to do the ones in the middle, because I can see that that sign is positive and that sign is negative. So I'm going to make these into 20y's. That means I've got to multiply all of equation 1 by 5. That will give me 15x plus 20y, and I'm multiplying the 2 by 5 as well, which will give me 10. Equation 2, I need to multiply now by 4. 28x minus 20y is equal to 36. So what have we got now? Well, we've got the scenario here. Let's just check we've multiplied all of this. 28x minus, I'm multiplying all this by 4. That's all multiplied by 5, and they stack up. Now, we've got the y's the same. So what we're going to do here is simply add the two. If we add these two now, adding these is going to give me a total of 43x. Adding these is going to make them disappear. 20y minus 20y disappears, and we're left now with this. Adding these two together, we're going to end up now with a total of 46. So x is going to equal 46 over 43. And that looks a bit messy, but it's the way it works. Now what we must do is now feed this in to find the y coordinate. It's always better to put it in the ones that you've got here. They're a lot easier to work with. So if we feed this in right now, it's probably easiest to put it into this one. So I'm going to get 3 lots of 46. So it's going to give me 3 lots of 46 over 43. And then we're going to have plus 4y is going to equal 2. And we can now solve for y. And this one is really messy. It's probably not a good one to choose. So what we've got now, that's going to give me 138 over 43. Okay, plus 4y. This really is quite messy, isn't it? And then I'm going to say now that this is going to be, I'll put this over 43 as well. So that's going to be, what we're going to have, 86 over 43. So 4y is going to equal 86 minus 138 over 43. Hopefully the next one will be slightly more favourable. That should give me, oh god, what are we going to have? We're going to have minus 52, aren't we? Minus 52 over 43 is equal to 4y, and then dividing both sides by the 4. So that'll leave us minus 13 over 43. Okay, tip of the day, don't pick ones that are going to end up messy. Right, okay, let's have a look at some alternatives. So that's elimination. What we'll now do is look at an alternative way to solve these by substitution. Now, what we've got here, and you can use either, we've got x plus y is equal to 8 and y is equal to 2x minus 1. And of course you can eliminate these ones. What we can also do though is see that this is 2x minus 1 is equal to y. We can just put it in here. So we get x plus 2x minus 1 is equal to 8. If y is 2x minus 1, we just put it in there. So we end up with 3x minus 1 is equal to 8. 3x is equal to 9. And then x is equal to 3. And of course we can just put it back in here. 3 plus y is going to be 8, so y would equal 5. So this is called substitution. Now, the way they've presented this is that we're asked to find the coordinates of points where they intersect. Well, the x is going to be 3 and the y is going to be 5. And we could actually show this graphically as well. We could set up some axes and draw these lines. So if you're any good at this, you'll see that that's, if we wrote this as y equals mx plus c, y is equal to minus x plus 8. So that's going to look something like that. Okay, and this is 2x minus 1. Okay, so what's that going to look like? That's going to look a little steeper and it'll look something like so. Let's just alter that just a touch. And what this is saying is, where are those 2 points intersecting? And the answer is when x is 3 and y is 5. So it's those points just there, and they're the coordinates. And of course you can do this graphically, but algebraically it's a lot tidier. But sometimes you'll have to. So let's use the substitution method for this one. X plus y is equal to 10, and we got y is equal to 2x plus 1. So we can put all of that in here and get x plus 2x plus 1 is equal to 10. So again, 3x plus 1 is equal to 10. X is going to equal, 3x will equal 9, x will equal 3. And then we just put that in. If x is 3, 3 plus y is 10, y is 7. And we can go back and use that method. We could have used this method here. For example, now this one, we could look at this, either of these ones now, and we could use substitution on this one, which we'll do now. I'm going to take this one to be right here. 3x plus y is equal to 5. And I'm going to say on the top one that the equation 1 can be written as x is equal to 5 minus 2y. All I've done is change its sign. X is equal to 5 minus 2y. And equation 2, we've got 3x plus y is equal to 5. Well, all of this is x, so we could write this as 5 minus 2y plus y is equal to 5, or any other possible combination. So we're going to get 15 minus 3y, sorry, minus 6y plus y is equal to 5. Tidying up, 15 minus 5y is equal to 5. Subtract the 15 from both sides. Minus 5y is equal to minus 10, and then y would equal 2. And then of course you can just substitute that back in. If y is equal to 2, x plus 2 lots of 4, 2 lots of 2 is 4, so x would equal 1. So that is, and do check these work. If we look at that, 3x plus y is 5, and so on and so forth. So that's substitution. Now substitution has huge benefits when you're working with non-linear. These are all linear. You don't see any x squareds or y multiplied by x or any products at all. These are just linear. Often we come up against some nastier ones where we've got to use the substitution method. Now, with this one, we can look at this in terms of elimination. We could just substitute downwards. Y minus y is nothing. 3x minus 2x is going to be x. And then we're going to have 0 minus 1 is minus 1. Another way of looking at is if y is equal to 3x and y is equal to 2x, then 3x is equal to 2x plus 1. Subtract the 2x from both sides and x is equal to 1. And then of course you can just substitute that back in. Y is equal to 3x, well x is 1, so y would equal 3. So you can set these equal to each other. And it's one way of looking at it. You don't have to, but it's an opportunity for you to do that. So this one, if y is equal to that one and y is equal to that one, then 2x plus 6 is equal to 3 minus 4x. And then of course, adding the 4x to both sides, 6x plus 6 is equal to 3. Subtract the 6. 6x is equal to minus 3, and then x would equal minus 1/2. And then again, you just substitute that back into these ones. Y is equal to 2x, well x is minus half, so that would be minus 1, plus 6, y would be equal to 5. And again, check that works, and it certainly works in that one. So this is another way of setting these up. If we look at this one, we could do all manner of things with this. If we look at this, x plus y minus 3 is equal to 0, and x plus 2y plus 1 is equal to 0. You can use elimination on this one. So for example, if we wrote now, if we subtracted downwards, x minus x disappears, y minus 2y is going to give us minus y, minus 3 minus 1 is minus 4, would equal 0. Another way of looking at it is to make x the subject. X could equal 3 minus y, and on this one, x could equal negative 2y, negative 1, and then you can set those equal to each other, saying that 3 minus y is equal to minus 2y minus 1, because x is equal to the same. Adding 2y to both sides, we're going to have 3 plus y is equal to minus 1. Subtract the y 3 from both sides, and y is equal to minus 4. And then of course you can put it back in, and you'll end up with x equaling 7. So you can go for that route as well. Lots of ways you can do these. Right, let's see what else we've got on here. Okay, this is where we need substitution. This is the equation of a circle. X squared plus y squared equals r squared is the equation of a circle. And we've got a non-linear. So this time we've got an x squared plus y squared is equal to 5. And elimination's not the option here. What we've got to appreciate is that this says y is equal to x plus 3. So I've got x squared and then y squared. Well, if y equals x plus 3, then y squared is x plus 3 all squared. Now we can eliminate through substitution for y. So I've got x squared, expanding this out, x squared plus 6x plus 9 is equal to 5. Collecting everything on the left hand side, 2x squared plus 6x plus 4 subtracting the 5 is equal to 0. Halving it, x squared plus 3x plus 2 is equal to 0. And this will factor to x plus 1. X plus 2 is equal to 0. So we can see x either equals -1 or x is equal to -2. All we need to do at this stage is feed it back into the linear one. Don't chuck it back through there, just put it through this one. X is equal to -1. Well, -1 plus 3 is 2. So y would equal 2. And then if x is -2, -2 plus 3 is going to give us 1. And what this is showing is a circle. I'll quickly sketch up what this is representing. And this really will be a very sketchy sketch. Okay, let's just put that somewhere near centre. So this is just a circle with centre 0, 0 and a radius of √5. All that this is a line intersecting. Now x plus 3 is going to look something like this. So what we've got here, probably a bit like that actually. So what it's saying is we've got this point at -1, 2, which would be somewhere up there actually. Let's just make that a bit more realistic. -1, 2. Let's make it look a bit like that. All this is are the points of intersection here and here. So that's what those two represent, -2 and -1. Okay, so -2, 1 is there, and -1 at 2 is just here. So that one, this root here, the point of intersection is going to be that one, and then this one is going to be that one. Now, this one right here is slightly different, but no major hassles. We've got x squared minus y squared is equal to 12. So it's another non-linear one, and we've got y is equal to x minus 2. Now, at this stage, what you could do is you can substitute either in. You can either say y is equal to x minus 2 and put it through there, or x is equal to y plus 2. So what we've got now is the following. We've got x squared minus, now we're going to feed this in, x minus 2 all squared is equal to 12. Now x squared, and be careful right here, we're going to have in here x squared, and then we're going to have, what we're going to have with that, minus, let's work this out, minus 4x plus 4 is equal to 12. So, sorting this one out, x squared minus x squared is 0, minus 4 times minus, whatever I'm not trying to say, the two negatives make a positive. 4x minus 4 is equal to 12. 4x is equal to 16. And x is going to equal 4. So if x is equal to 4, then what we've got now is the following. X squared is, x is equal to 4. We just put it back through the linear. So y is going to equal 2. If x is 4, y is going to be 2. So these are a good example of what we call non-linear ones. Okay, here we are. There's some different ones. Find the coordinates of the points of intersection on the line and the curve in each case. Apologies, it's gone off the screen. Now again, we've got a quadratic graph here. That quadratic is going to look something like this. Okay, we're going to have x squared minus 4, which is a parabola. It's an upward opening positive parabola, and it will look something like so. It will come up through here, give or take. It's going to have a solution now at positive and -2. And then what we're going to have here is the line y equals x plus 2. Okay, and this is going to look something like this. So what you can see is that we're going to have 2 points of intersection on here. on this one. So what we need to do is solve this algebraically. You can show graphically it's got two solutions. Now if y is equal to x plus 2 and y is equal to x squared minus 4, then x plus 2 has got to equal x squared minus 4. Dragging everything to this side and setting to 0, x squared minus x, and then we're going to subtract 2 is going to give us minus 6 is equal to 0, and this will factor, and this will give us x, and then we're going to have plus 2, x minus 3 is equal to 0. Now we can see that x is going to satisfy this one right here when x is negative 2, and then we can see the other one is when x is going to be 3, which is going to be up here. So x would be 3, and of course we can find the y coordinate of 5. If x is 3, 3 plus 2 is 5. So these are points of intersection. And again, it can work with any of these sorts. If y is equal to this one and y is equal to that one, then they equal each other. So x squared plus 3x minus 1 is equal to 4x plus 11. Taking all to the left hand side, x squared minus x, and then we're going to have minus 12 is equal to 0. That too will factor as x plus 3, x minus 4. So x is going to equal negative 3, or x is going to equal positive 4. And you can simply find the y coordinate by substituting it back through the linear. Make this easy for yourself. If x is minus 3, minus 12 plus 11, what we're going to have minus 1, y is equal to minus 1. And then on this one, if x is 4, we're going to have 16 plus 11, y is going to equal 27. Sounds about right. So these are typical examples of where we've got a quadratic, that's a parabola, that's a parabola, and that's a parabola. And we just solve them in terms of simultaneous equations. So basic sort of flick through of what we've looked at. We've looked at, perhaps this is running for a moment, I'm going to pick it up. You've got the choice. Elimination with these linear ones. Elimination's a possibility by simply making the coefficients in front of the x or the y the same. Once you've got them the same, if the sign in front of those is the same, you subtract downwards. If it's different, you add. We looked at the substitution method when we we did this. So if x plus y equals 8 and y is equal to 2x minus 1, we just substitute that in. So we put it in and then solve. We showed it graphically. And then the other methods are when we had, where are they, somewhere? Here we go, linear with a non-linear. We feed the linear into the non-linear, solve for potentially 2 or more solutions, and then we get the solution for one and put it back through the linear. So that was when we were substituting. And on the other ones, the quadratics, technically we were looking at substituting, but we were just setting the y's to be equal. So hopefully that's given you enough info on simultaneous equations, and will certainly take you through GCSE and the start of your AS or A level.